お待たせいたしました。それではセッションを再開いたします。続きまして、OpenStack における迅速なアプリケーション開発とその展開についてと題し、Co-Founder and Chief Scientist Piston Cloud Computing Inc. クリストファー・マクガウン様にご講演をいただきます。なお、当セッションでは同時通訳がございます。チャンネル1番で日本語をお聞きいただけます。同通レシーバーがお手元にない方は、スタッフがお配りいたしますので、挙手をお願いいたします。恐れ入りますが、同通レシーバーはご利用後退出される場合は、会場出口にありますカゴの中にお戻しいただきますようお願いいたします。それでは、クリストファー・マクガウン様、お願いいたします。
Hello. My name is Christopher MacGown. I'm the co-founder and chief scientist of Piston Cloud. I am here today to talk to you guys about FarmBoy, which is an open source framework or an open source application for delivering and deploying applications into OpenStack clouds. I tend to talk very, very quickly, so I've asked my friend Yoshi to, if I do, get up and kick me so that I'll slow down. At Piston Cloud, we're some of the most opinionated people in cloud today. And I give very controversial talks, some of which has gotten us in trouble in the past, and so I've tried to tone it down a little bit today. Some of the talks that I've given in the past have been about things like Ceph and the production nature, production quality of it. I gave a talk on using Ceph in production in 2011, and again in 2012. And in 2013, Ceph has become one of the primary use cases behind the OpenStack community today. Also in 2013, I gave a talk about exactly what OpenStack is, which ended up controversial because it sort of spawned the RefStack movement, or the RefStack project within OpenStack, to define how OpenStack is termed and used, and how the OpenStack trademark can be applied to products and projects that consist of the projects that OpenStack provides. And last but not least, I recently gave a talk on the suitability of software-defined networking and the status as of 2013 on whether or not Nova Network was more suitable for software-defined networking than Neutron. So I like to give controversial talks. And today, I'm going to talk to you about DevOps. DevOps, as a movement, has been primarily defined by the ability of developers and systems operators to work together to deploy applications. And that is very good when you're deploying into production from test or into test from development. But doesn't tend to work in the same easiness when you're deploying to development environments. And the existing tools, your Chef, your Puppet, your CF engine, they primarily focus on the needs of operators over the needs of developers. And too much work has been done turning these tools into frameworks instead of simple tools. And the controversial statement I'm going to suggest is that these tools should be more like POSIX tools, the tools you use on Unix machines, on Linux machines, to compose tasks of work where you can pipe data from one tool to another rather than monolithic application frameworks. And the other controversial statement I'm going to say today is that DevOps as a movement has been hijacked. It's supposed to be about making it easier for developers and operators to formalize deployments, and about making it easier for developers and systems operators to communicate with one another. But as a business person, oftentimes it's easier to, or it's used as an excuse not to hire a systems admin or another developer. The tools that exist currently presuppose that developers love frameworks. And as a developer, we've all written one. We all have decided that the frameworks we're going to use aren't good enough, and so we re-implement them. But the real statement is that developers hate frameworks. That's why developers have rewritten them and write them consistently. I mean, who here hasn't written a framework? The truth is, developers love code. Chef and Puppet made operators' lives easier by allowing them to distill the facts about a system into a easy-to-read, declarative language that describes what the systems do. But the problem with that is that developers don't use them. When developers are deploying their applications, when they're testing their applications, and when they're developing their applications, they're not pausing to update chef recipes or Puppet scripts. They're trying to get their code onto a machine so that they can test some parcel of work as quickly as possible. And despite that, the DevOps community has risen up around tools like Chef and Puppet with the expectation that the current idiosyncrasies or the current state where developers are doing their own thing, and that is getting translated at some point in time into parcels of work for the operators to deploy, it just doesn't hold true. The primary example I'm going to describe today is the OpenStack community. OpenStack is built on open source software. It is built using continuous integration, and built using open source tools like Git, Reitveld, or Gerrit. And despite the fact that these tools or this OpenStack ecosystem is built and has recipes for all of the existing tools, you can deploy OpenStack with Chef, you can deploy OpenStack with Puppet, you can deploy OpenStack with Juju, you can deploy OpenStack with my own distribution. There are many ways to distribute and deploy OpenStack, but the OpenStack developers don't use any of these tools in their development. They use DevStack. And DevStack is a collection of shell scripts, very brittle shell scripts, to allow you to deploy OpenStack services in a virtual machine or onto a bare metal host for the purposes of testing some piece of code that you've written in OpenStack. And that's good for the OpenStack community. They've built tools around how they can do this. But from a wider community's perspective, you can't reuse DevStack for your own applications. And DevStack presupposes that it's going to be installed inside a virtual machine anyway. So if you're building applications on top of cloud, on top of OpenStack, on top of Vagrant, on top of the Amazon Web Services, you already have to bring these virtual machines up and running in order to deploy your applications into them. So instead of building yet another shell script, we wanted your developers to be able to deploy their apps in a way that was consistent, repeatable, and used the same mechanisms that developers use to communicate with themselves. And that tool we call FarmBoy, which, like many of Piston Cloud's internal code names, comes from a movie called The Princess Bride. FarmBoy is a simple tool and a library for rapid development and deployment of applications. It's focused on the needs of developers, and it's simple. It's an extension to Fabric, which if you're a Python developer, you know allows you to operate against remote machines using Python code to execute applications on the host. It's open source. It's available on GitHub. It's continually being developed and upgraded by Termi, who was one of the original developers of OpenStack Nova, OpenStack Keystone, and OpenStack Neutron. It works with Amazon Web Services, OpenStack, and Vagrant. And the way you use it is code. You write Python code to deploy your applications. If you're a Python developer, you already know how to use it. And if Chef and Puppet allow your operators to act like developers, by enabling them to do or enabling a repeatable process on their own terms, FarmBoy does the same for developers. It allows your developers to act like operators, but instead of acting or becoming an operator, it allows them to write software to become an operator. Now, I'd like to demo FarmBoy, and hopefully the Wi-Fi is working. If not, I'll have to fake it. So please bear with me. Awesome. Can everybody read that? Is that legible? What's that? Only to the back? All right. One. Okay. So, Farm Boy. When you run Farm Boy, as you can see, I ran through this demo earlier today. Farm Boy has a list of commands, including the commands that are defined in the Fabric file that it generates. I'm not going to go through the whole process of generating a new Fabric file, but I will show you that as part of this. And as the Farm Boy application is getting deployed, I will show you some of what's coming in our next release of Piston OpenStack. This is a lot of code. We don't need this one. We don't need these because we're not deploying them. So we'll clean these up. With Fabric, when you define a role or define a type of machine, you give it a name. And that name corresponds with a role that gets attached to a task. In this demonstration, I will be deploying a very small Django application into an OpenStack cloud. That OpenStack cloud is over here. As you can see, there are no instances running. There's nothing behind the curtain. There's nothing in my sleeves. And part of this, make this larger, has some definitions about the environment that Farm Boy will be using. By default, Farm Boy makes use of YAML, which is a very lightweight serialization format, and defines or has some expectations around the metadata that the images or the instances will be launched from. Over here, I've defined that very lazily, calling the MySQL password secret and the MySQL CloudOps password also secret. And the instance type ID or the flavor ID is just pulling out of the OpenStack flavors. And the image ID is the UUID of the glance image that we'll be installing from, which is an Ubuntu 13.04 instance. And when I ran this before, the installation created some role definitions which corresponded with the virtual machines that will be created and the IP addresses that they had. However, I've deleted those VMs, so these IP addresses are no longer relevant. So I'm going to remove them. If you're familiar with Fabric, Fabric allows you to define tasks and then execute them on the command line. In this case, what I'm defining is an Ubuntu upgrade task that will install various packages and only execute on the nodes that are defined as web nodes. I've also created a demo task that will execute MySQL deployment, MySQL user create for both the Django app user and also the default user. It will upgrade Ubuntu to use the packages that we defined. It will deploy HA proxy. It will deploy Nginx, which is a web server. And it will deploy Gunicorn, which is a Python Whiskey app server. And then finally, we will deploy the Django application. And then finally, it will tell me where to go to see what's going on. In addition, so you're going to be able to hear? Or? Oh, it's your phone. OK. So the Django application is a Django application. As you can see, it exposes one view. The view is high. But because it's a Django application, this could be an actual meaningful application. In fact, we use FarmBoy to deploy RefStack for the OpenStack Foundation currently. But that would be too much work, so I've only got this little one. In OpenStack, when you connect and log in, you can download an openrc.sh, which is a shell script that defines the environment variables to point to your cloud. And FarmBoy makes use of the same environment variables as the OpenStack clients as well. So to deploy on OpenStack, you run the FarmBoy OpenStack build command, and it'll start 4 instances, and then wait. On the admin project, you see we have now 40% of our quota instances used up. And these instances are now spawning. And while that's going, I'll click around. The Ubuntu 13.04 image we installed through the OpenStack dashboard. And we'll be authenticating, or FarmBoy itself will be authenticating via key pair that the OpenStack, or that FarmBoy installed into OpenStack as part of the build. Okay. The instances are now active. Then my application deployment function, or my application deployment task, is called demo. And you'll notice that it dumped the role defs to farmboy.yaml. Which now defines our IP addresses for these various roles. What is hidden in this demo is the fact that each of the actions I've done, the MySQL action, the Ubuntu install, the HA proxy install, all of these are tasks that is already built by Farmboy. So we're installing Farmboy, or installing our application currently. This will take a while. So in addition, I was asked to show some of the distinctive features of Piston OpenStack. And part of that is when you do a deployment, as part of the boot nodes process for defining where or how the hosts get brought up, there is a process that runs on the boot node that identifies the hosts and provides access to the logs and information from that. So you can see the state of the hosts. And this is a development cluster that's used internally. So there's only a single host available currently. But if there were more servers in this cluster, they would show up on this panel here in the dashboard. And they would be able to seamlessly be added to the cluster after they had been brought up by the system as a whole. So what is happening now is we are installing MySQL, and it's creating the user for that. So this may take a little bit of time because this is a remote system and it is installing packages off of Canonical's Ubuntu dev packages. So I have time to take questions while this is happening, and then afterwards we will see the output of the application as it's getting installed.
それではご質問あります方は挙手をお願いいたします。質疑応答へと移らせていただきます。ご質問いかがでしょうか。それではただいまマイクをお持ちいたしますのでお待ちくださいませ。
日本語ですみません。このファンボーイという、開発環境というかコマンドセットだと思うんですけれども、これは今シェルスクリプトのように扱ってらっしゃいましたが、いろんな言語体系からも呼び出しができると、そういう理解でよろしいでしょうか。例えばPython であるとか C であるとかそういったものからもこれを呼び出すことができると。
So you can take or use Python. you can use Python to execute FarmBoy tasks. Currently, you cannot use C, but I believe that the goal for FarmBoy long term is not that we make it so that it can be executed from Java or C or any other language, but that we make it possible for developers in that language to build their own applications that work in the idioms of that language. So FarmBoy is very Pythonic. It would not translate well into Java or Ruby.
Thank you very much.
ありがとうございました。その他ご質問いかがでしょうか。よろしかったでしょうか。それでは以上をもちましてご講演を終了とさせていただきます。
So, if there are no more other questions, we are almost to the end of our demonstration.
続けさせていただきます。失礼いたしました。
Excellent. Our demonstration is finished. Our application is now running. Oh no. I have to type the whole URL in. So I don't speak Japanese, but I think that says OpenStack wa Nihon konnichiwa. And then the teardown is very easy too. So. Thank you.
ありがとうございました。
ありがとうございます。